Cheat Engine is the program that introduced me and thousands of others to the world of game hacking. And ever since then, it's been an increasingly useful tool in my personal arsenal. Most people think that it's just used by noobs and script kiddies, and while they are mostly correct, a lot of experienced developers continue to use it regularly when developing their cheats. It's a whole game hacking platform with multiple debuggers, a detailed memory scanner, a disassembler, and much more. It lets you create and share scripts, cheat tables, and even make full trainers with user interfaces that you can share with your friends. It's a foundational program that you must learn if you want to hack games. And that's why today I'm going to give you guys a full overview of the program and its features. Hopefully I can show you its potential and get you on the track to learning it. At the end, we're going to walk through the official Cheat Engine tutorial together as an introduction. I hope you enjoy the video and learn something new. So without further ado, let's get into it. People often ask me what the most important skill is for a game hacker to learn. And while there are tons of programs, techniques, and languages to recommend, I'd say the greatest skill to learn is simply problem solving. That's why this video is sponsored by Brilliant.org, an online learning platform dedicated to teaching you how to think. It's a place where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and even AI. Brilliant helps you build your critical thinking skills through problem solving, not memorizing. So while you're building real knowledge on specific topics, you'll also be developing into a better thinker. Brilliant's growing number of programming courses are a great way to build foundations and learn real-world applications. For example, you can get familiar with Python and start building programs on day one with a built-in drag and drop editor, effectively developing your mind into that of a programmer. So whether you're a student looking to ace your exams or a professional looking to upskill, you can try everything Brilliant has to offer free for a full 30 days by visiting brilliant.org/cazz or by clicking on the link in the description down below. You'll also get 20% off an annual premium subscription. Thanks for listening, and let's get back to the video. Before you can use Cheat Engine, you obviously need to get your hands on a copy. It's pretty simple. You can either download it from the official cheatengine.org website, or you can get it as a release from the GitHub repository. At the moment, Cheat Engine 7.5 is the latest version, and it's completely free and open source. Run and install it like any other application, but keep in mind that it might come up as a virus or a potentially unwanted program, so you may need to add an exclusion for it with your antivirus. Cheat Engine is certainly most well known for its memory scanner, which you are immediately greeted with when opening the program. Before using it though, you need to attach Cheat Engine to your game so that it can access the memory. The memory scanner is very customizable and gives you a lot of options to use when searching for values, such as the type of data, different scan options, a memory range to search within, and much more. Usually you'll find yourself searching for exact values. For example, the game might display your health value as 100. In Cheat Engine, you would search for 100, which will net you thousands of results. Back in game, you should take some damage and search for the next value. Keep repeating this process, and eventually you'll narrow down the results and find your player's health address. Sometimes you can't see the exact value that you're searching for. Imagine your health is stored in a health bar, for example. Cheat Engine will let you initially search for an unknown value. Then, once you take damage, you can search for a decreased value. Keep repeating the process just like before until you find the correct address. Once you find a value of interest, double-click on it to save it by moving it to the bottom panel of the screen. Here you can store all the important addresses in your current session to compare them or change them later. Below the memory scanner, you'll find a memory view button. Clicking this button will disassemble the game and show you its instructions at a particular address. This will give you a lot of clues into the inner workings of the game once you become a bit more familiar with reading assembly code. Furthermore, you can edit the game's assembly on the fly because Cheat Engine also comes with an assembler. For example, let's say that you find the instructions that subtract your health in the game. You can select them and knob them to disable those instructions, effectively disabling the game from subtracting your health. One really useful toolset that Cheat Engine comes with are its mono behavior features. If you happen to be messing around with a Unity game, this makes the reverse engineering experience infinitely easier. You can dissect mono to expose the game's entire class hierarchy. This includes the class names, methods, and fields that make up the game. This is amazing because you don't have to reverse engineer everything from scratch. Instead, Cheat Engine will show you everything in a readable format, allowing you to analyze and modify the game's structure with ease. It's great that Cheat Engine has all of these features to offer, but what if you want to save your progress and share your creations with your friends? Well, Cheat Engine has you covered with so-called cheat tables. These are pre-made scripts or configurations saved as .ct files that can be shared and loaded into Cheat Engine. They usually contain a set of addresses, pointers, or even Lua scripts that are specific to a game. This means you don't have to do all the scanning work yourself if someone has already created a cheat table for you. It's essentially like loading a trainer, but with the added flexibility to modify or expand on it yourself. Many cheat tables also include toggles for things like infinite health, money, or ammo, saving you a significant amount of time. For advanced users, Cheat Engine includes a kernel module called dbvm. This module allows Cheat Engine to bypass certain protections in the operating system or the game itself. For example, some games employ anti-debugging or anti-cheat measures that block Cheat Engine's default functionality. By loading the kernel module, you can gain access to protected memory, avoid detection, and debug programs with higher privilege levels. Most large multiplayer games specifically look for and block the use of Cheat Engine, so this can be pretty useful to access those games. Alright, what's going on everybody? Welcome to the tutorial section of the video. For those of you wondering what I'm yapping about, Cheat Engine actually comes with an official tutorial built right into the program. That can be accessed from this help menu right over here. You'll find a 32-bit version and a 64-bit version, the latter of which we're going to be using because we don't live in the 1980s anymore. So go ahead and click on that once your Cheat Engine is open. This is going to bring us to the introduction page to the tutorial. Excusing all this writing over here, all it's telling you to do is connect Cheat Engine to the tutorial, which is pretty simple. You see this glowy button over here that's basically begging to be clicked. Select that and double click on the tutorial to go ahead and open it. Before we go any further, I'd like to recommend that you try and do this by yourself, and if you get stuck, come back to the video if you're actually trying to learn Cheat Engine and care about it. If you just want to see how it works practically and everything like that, then stick around because I'm going to show you exactly how all of this works. Anyway, to move on to the actual first step, we're going to go ahead and click this next button. This brings us to step 2, exact value scanning. Now, this was mentioned earlier in the video. It's called exact value scanning because we know the exact value, and even if we decrease the value with this button, we can still see the value the entire time. This is about as simple as it gets. Now, there are a few things to note about this value over here. First of all, we can see that it is a whole number. There's no decimal point with numbers after it. It's just a whole number, and whole numbers are usually integers, and integers usually are 4 bytes large, right? That doesn't mean that this isn't a float somewhere behind the scenes that's being rounded off when it's displayed or anything like that, but because we're doing a tutorial and it's the first step, there's a very, very high chance that this is a 4-byte integer. So on the memory scanner over here, we're going to make sure it's still set to exact value and 4 bytes, right? 4-byte integer, that's what we're looking for. To do our first scan, we're going to search for 94 and hit the first scan button. We get 2 results. That's one too many. So let's go ahead and hit me, and you'll see out of our 2 results, only one of them changed, and that basically immediately tells us that this is the value we are looking for. So double click on that and then double click in the value column over here and change that to 1000, hit OK, and that is going to unlock our next button over here. Let's go. Alright, so before we do the next step, we need to kind of reset our Cheat Engine over here. I'm going to hit the new scan button to reset the memory scanner, and I'm going to hit this button to delete all of the addresses that we've saved. Now we move on to unknown initial value scanning. This was also mentioned earlier in the video. This is for the case where you can't actually see the value that you're starting off with. As you can see, we cannot see it. This is most useful for video games with health bars, or where you can't see your ammo, or even trying to find your position in a game. To get started with this, we are still going to be searching for a 4-byte integer, because if we click hit me, you can see it's still decreasing by a whole number. So it's very high likelihood it's still going to be a 4-byte integer. So let's go ahead and change from exact value to unknown initial value. Let's do our first scan, and we've netted over 500,000 results, which is about 500,000 results more than we want. Let's go ahead and hit me, and that decreased by 5. We can change this to value decreased by, and it decreased by 5. Next scan, and you can find that we have all of these. Now, they actually say in this tutorial that the value is between 0 and 500, so it's pretty safe to assume that this is the value. To make sure we can hit ourselves again, I guess it's just like some guy punching himself in the face or something, but it's gone from 33 to 26. Pretty confident that this is the one, and we're going to go to the value and change it to 5,000 because that's what they want in the tutorial over here. And yeah, we can go ahead and hit the next button. Alright, so that takes us to step number 4, floating points. Let's go ahead and reset our Cheat Engine once more by hitting this button and the new scan, and let's talk about this. So this is going to be pretty much exactly the same as exact value scanning, except we're going to change the data type to float and double. They made it super duper easy for us. They literally tell us that it's float and double, and obviously we can see that because there are decimals being used over here, if I could get one right there. So let's go ahead and do this. It's going to be exact value still, but we're going to change to float because we're going going to search for our health first, and we are going to enter 78.5, and of course, sorry, 0.8, whatever it is on your computer, it will be different. First scan, and we find it immediately. Pretty simple. Now let's double click on the description just to rename this so that we can keep track of what we have there. Go ahead and click new scan to reset your memory scanner, and now we're going to change from float to double. Let's enter in the value 98.5, and they've kind of hidden it away down at the bottom here, but hint, it is recommended to disable fast scan for type double. So let's go ahead and do that and listen to them because they know best. So first scan that, and we immediately get it. So this is going to be our ammo, because somehow you can have 98.5 ammo, whatever that means, and they want us to change both of them to 5,000 or higher. So let's go ahead and change the values to 5,000, just like that. And now we have access to the next button. So let's go. Okay, step 5 out of 9. Now we are on the code finder. So the goal of this step is to basically replace instructions that are changing your value over here. So this is just a random value. We can imagine it's your health. As you can see, it's constantly changing. How would we be able to stop it from changing? Well, you could either freeze it by clicking, these buttons if we had the correct address. But what they want us to do is to actually NOP the address, which means we're going to replace the assembly instructions with no operations. We're searching for the value 852. We're going to be searching for a 4-byte integer, and we can have fast scan on again, 852 first scan, and we get 2 addresses. Let's change the value, and we see that this top one is the only thing that changed, and it's 282, it corresponds. But yeah, so let's double click on that to get the address down into the useful box down here, and we're going to use a very useful feature. Right click and say find out what writes to this address. So as we know, something is writing to this value when it changes, right? So you can see here when I click to change the value, we're getting the exact line of code in the disassembly that is actually changing the value. We can see it's moving EDX, which is the new value, into RAX, which is the old value. So this is pretty simple. To remove this instruction from having any effect, we just click this replace button, and then you can ignore this and hit OK. Now we can stop this debugging thing, close out of it, and if we try change the value now, you find that nothing happens. So yeah, cool. Next. All right, so that takes us to step number 6, where things start to get interesting, because now we're talking about everybody's favorite topic, pointers. Pointers are used throughout games, and you're always going to be running into them, so it's very important that you get acquainted with them and how to find them using Cheat Engine. This first pointer example is very, very simple. It's just a single level pointer, a pointer that points to a memory that we want. Also take a shot every time I say pointer, you might die. Down here we have 2 buttons. We have change value, which just changes a random value, and then we have this change pointer button, which changes the pointer that points to this value. The first step over here is basically we need to find the address right now of the value, which is what we've been doing this whole time, right? So 686 is what we're looking for, 686. Also, yeah, remember to reset your Cheat Engine. Let's go ahead and do our first scan. Hitting this change value again, we find that one of these results has changed, so we know that it is in fact this one. Now, to demonstrate why this change pointer thing is very useful, maybe when a map changes in your game or something like that, imagining this is your health, the pointer is going to change. And if I hit that button and wait for a few seconds, you're going to find that the value changed, but it's no longer updating in the address box over here. You can see it's now stuck. And that's because this address is no longer valid. So that was just demonstrating why this is, or what we're actually doing here. We need to find the pointer to that value, and then we'll always be able to have that value. So let's go ahead and search for the pointer again. Let's go ahead and search for the address again. First scan and change the value, and we found it yet again, 789, it's this one. Now we're going to go ahead and right click, and we're going to say find out what writes to this address. And now when we say change value, you can see the instruction. It's pretty much exactly the same as we saw the last time. So let's go ahead and double click on that. We have EAX being moved into RDX. EAX is going to be the new number, RDX being the old number. And we can actually see right above here, we have this long address that's being put into RDX. So that is the value of RDX. That means that this is actually the address of the pointer that is changing the value of RDX. So let's go ahead and double click on this to open it up in the disassembly. And over here, you can see tutorial x86_64 plus a certain offset. And this is actually the pointer to what we need. So I'm going to go ahead and open up a notepad here quickly, right click, and I'm going to copy. Where is copy? Yeah, copy to clipboard, and we're going to go ahead and get the bytes and opcodes, paste that in, and we are looking for this right here. So let's go ahead and copy that. And now it's pretty simple. We can actually close out of this, close out of that. Okay, stop,
close out of that, and add address manually. Now we're going to select pointer, and we are going to paste that in. And immediately you can now see that 196, 196. So we now have a pointer. You can see P is pointing to the same address. Now you'll see that if we change the value, they both update. But if we change the pointer, you can see that this pointer one still has the correct value, but the other address is now invalid. So yeah, that's how you would find a very simple single level pointer. Single level meaning that it's literally just the module plus an offset. We'll get into multi-pointers a little bit later. Anyway, to unlock the next step, we are going to go ahead and what we have to do here. Change the value of the pointer to 5000 and then freeze it and then hit the change pointer. So let's go ahead and do that. Changing the pointer value to 5000 and then freezing it, which is this box over here, which means that Cheat Engine is basically just going to constantly write 5000 to the address. And let's hit the change pointer button. Awesome. We have now unlocked the next step. Cool. Moving on to step 7 out of 9. Now we are going to be doing some code injection. If you remember in step 5, we did actually a little bit of code injection because we replaced an assembly instruction with a NOP, right? We made it a no operation, but you can actually put your own custom assembly instructions in, right? So in this case, here we have a health and we have a button that says hit me, which decreases our value by 1 every single time, our health value, right? The goal of this is to change that instruction to, instead of subtracting our health by 1 every single time, we actually want to add health by 2 every single time. I hope that makes sense. So we're going to change it from subtracting 1 to adding 2. And I'm going to show you how to do that. So let's reset our cheat engine. And we first of all need to find the health value, which is yet again going to be a 4-byte integer, 87, first scan, hit me, and we find it immediately. Now we're going to do the exact same thing we've done in like the past 4 steps. We're going to find out what writes to this address. Hit ourselves again right in the face and look at that instruction. So we have 1 being moved into the location of RSI plus 07E0. So if you can imagine this logically, RSI is probably going to be your player pointer, and then plus 7E0. That's going to be the offset of your health. And what we are going to be moving is 1, but we're not moving. Look at this instruction over here. We have sub. Sub means subtract, obviously. So let's show in disassembler. It shows us the exact same thing. So let's right click and we are going to click this assemble button. And now we can actually change what we want to do here. So instead of sub, we're going to say add, and we're going to change the value of 1 to the value of 2. So this is going to do the opposite thing. Instead of subtracting, it's now going to add the value of 2 to our health. So hit OK and close out of that, and we can stop this. And now if you hit me, look at that. Our health starts to go up instead of going down. We just modified the game's code like absolute badasses, okay? So yeah, now we can move on. All right, ladies and gentlemen, that takes us to step 8, multi-level pointers. In step 6, we had a simple level 1 pointer, which was literally just a pointer to the value that we want. But now we're going to deal with a level 4 pointer, which means that we're dealing with a pointer to 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 the health eventually. It's pretty much the exact same process as we did in step 6, except we just need to repeat it about 4 or 5 more times to get the correct chain. Now, for those of you who are curious and wondering how exactly we get to a point like this, where we can have a pointer to a pointer to a pointer, it's extremely common, and it happens because of this. So I've written some very basic C++ code here to kind of show you how we get to this point. Imagine you have some sort of a game engine with the context being stored in this g_game pointer. Game has access to the world has access to the player list, and of course players have access to the health. If you take a look down here, this is kind of the example of what code would look like if you're trying to access the health of a player. You'd go from the game to the world to the players. Here we are indexing the player list because it's a list of players, and then eventually accessing the health. So I kind of hope that makes a little bit of sense. But anyway, without further ado, let's get into the mission that is finding this multi-level pointer. So we're going to start like we've started every single time. We're going to search for this number 1796. First scan, and we find a lovely address. We find it the first time. Let's just make sure that the value is correct here, which it is, 1796. So we're going to go ahead and add that to our address box. Now we're going to right click and we're going to find out what accesses this address. When we change the value, you're going to see that we have these 2 instructions accessing the address. It's at this point that you probably want to pull out a notepad because we are going to need to store some information here. If we double click on one of these, we can see that the instructions around it are not very helpful because we have some sort of a mov of an offset into ECX, and then we have a call. So we're calling functions over here, which means that the code is being directed into other places. So we're not interested in that. But what we are interested in here is this offset, plus 18. The reason that's important is because if I come here and add an address manually and I switch this to pointer, you're going to notice that we can add offsets. And these are going to be the offset to the next pointer from the original pointer every single step of the way down the chain. And we can essentially just assume that the final step is going to be 18. So I'm going to write down plus 18 because that is in fact going to be the final offset in this pointer chain. Cheat Engine is very nice to us because they say the value of the pointer needed to find this address is probably whatever this is. And how does it get that? Well, if you look at the value of RSI, which they show us right here, 015 blah blah blah, it's the exact same number. So if you don't understand how Cheat Engine is guessing what the value of the pointer is, well, it's because it's looking at the value of RSI. So let's go ahead and copy this. Okay, and we can close out of all of this good stuff. That little note told us that it's the value of the pointer that we're looking for. So we're going to change to hex. We're going to paste in that value and we're going to hit a first scan, and that'll get us another result. Sorry, I'm just trying to move this to the top here. So now if you take a look at what we have here, we have the value of this address over here is actually the address of where our health value is stored. Can you see that connection over there? This is essentially what we have to do about 3 more times. So let's right click on this new one, find out what accesses this address, and we are going to go ahead and change the value. And as we can see, we find no offset being added to RSI this time. So that means that the second level of indirection is going to be plus 0. This will make a little bit more sense when we enter it into the final pointer. But for now, we need to double click on one of these instructions and we need to go ahead and copy Cheat Engine's guess because Cheat Engine's guess is correct. So copy that. Okay, stop, close out of this, and we do a new scan. Once again, just to confirm that we are on the right track, you can see that the value of this address is actually the address of the one above it. And then the value of this one is the address of this one, and that eventually leads us to the number that we want, which is 1090. Anyway, so we got to continue this process a few more times, find out what accesses this address, and then we're going to go ahead and change the value. As we can see now, we have another plus 18. So let's go to our notepad and add another plus 18 because that's going to be the other offset. We can stop, double click on any one of these and copy Cheat Engine's guess, and we can go ahead and make a new scan, paste, first scan, and now it gets a little bit more confusing because we have 2 values. So we actually need to figure out which one is being used, which one is the correct one. So let's start with the lower address because they typically are lower addresses. So I'm going to right click and I'm going to find out what accesses this address. Let me change the value, and as you can see, nothing is actually happening over here. So that pretty much tells us that that is the incorrect address. So I'm going to remove that because we don't want to get confused, and we're going to get the higher address. Now, if we do the exact same thing, find out what accesses this address, change the value, and would you look at that, we have 2 instructions. We can see the offset over here is plus 10. So we're going to add plus 10 to our little notepad over here, which is keeping track of the offsets. We're going to double click on one of these and we are going to copy this easy guess once again. And we can exit out of this. New scan, paste that in, and let's do our first scan, and would you look at that. Now we have something called a static address. That's what these green addresses mean. And if you ever are searching for a pointer and you find a static address, that means that you have in fact found the correct base address for the pointer. So we're going to go ahead and add that. Now, in order to complete the whole pointer chain, it's pretty simple. On this thing that we just added, the static address, we're going to double click, we're going to change it to a pointer, and we're going to start filling in these offsets. So remember, the first step was plus 10. Then we're going to add an offset, we're going to get to plus 18. Then we're going to add another offset, which was just 0. And we're going to add another offset, which was 18 once more. And we're going to change this from hexadecimal to not hexadecimal. And would you look at that? Look at the value it's pointing to, which is 2088. Go back to the tutorial over here. You can see that 2088, in fact, is the number we are looking for. If I hit change value, you can see that they both update, but if I change the pointer, you'll see that this is now invalid. This is still 2235. So that means that we have found the correct pointer chain. We can delete all this other stuff. And now we need to actually read the instructions and figure out what they want us to do. Click change value to let the tutorial access health. If you think you found the pointer path, click change register. The pointers and the value will then change and you'll have 3 seconds to freeze the address to 5,000. So we got to do this kind of quickly. Let's go ahead and change pointer. We're going to set this to 5,000 and then freeze it. Okay, I was a bit late there, but let's change pointer again. It's frozen at 5,000. Okay, that's all I had to do. So set it to 5,000, freeze it, and then you'll get access to the next part. Alright, ladies and gentlemen, now we find ourselves at step 9 out of 9, the final step, shared code. What we are presented with here is this little game where when you click attack, it decreases a bunch of players' health, right? But the problem here is that we have the players on the left side over here who are on our team, and we have players on the right side who are on the enemy's team. When we restart game in autoplay, you see our team dies because we have less health. So let's restart the game and reset everything. The goal of this is to freeze our health on our team, but allow the enemy's health to continue decreasing. Now you probably are wondering why this is a problem. Why don't we just freeze our health? Well, I'm going to show you exactly why this is a problem. So what they have done here is they've changed from 4 bytes to floats. So our health is now a float. So let's go ahead and find our health values. So first scan 100, attack, and we can see that this is the value that changes. So let's grab that and let's see what's going on here. Right click, find out what writes to this address, and let's attack. And as you can see, here is the instruction that is in fact decreasing our health. Let's go and show in disassembler and take a look what's happening here. XMM0 is being moved into RBX plus 08. So remember, we're using floats. So now these are going to be stored in the XMM registers. And this is the amount to decrease. It's being moved into RBX plus 0x8. So health is obviously being stored at 8 and RBX is our player's pointer. Let's go ahead and right click and replace this with code that does nothing. And you'll see now that if we try and decrease our health, well, it works. You know, it stops our health from being decreased. But we have run into a problem because if we try and deplete the enemy's health, they are also being frozen. So why is this? Well, it's because every single player is being run through this exact same function. The only thing that is in fact changing is the address of the player that was in RBX. Obviously, I've knopped the instructions, so we can't see that anymore. But this is the problem that we are facing. Right now, our solution is basically giving every single player in the game God mode, but we don't want that. We only want ourselves to have God mode, the people on our team. Let's try and figure out how we can distinguish between our team and the enemy team. I'm going to right click and I'm going to restore with the original code because I was just showing you that as an example, and now everything should work again. So let's go back to this instruction that we had over here in the debugger where we found out what writes to this address. Let's right click and let's say find out what addresses this code accesses. We can close out of the debugger, and this is a very useful little box because it's going to show us each address that's being passed through this function, right? Or this instruction. So let's go ahead and attack ourselves if we are Dave, and we can see that there is the address of Dave. And let's do this for every other player. So now we have every single player in the game. We found them pretty easily, and now we're going to use some cool cheat engine functions. So let's shift click the top two because we know that they are on our team. We're going to right click and we're going to say find commonalities between addresses, and we're going to mark this selection as the first group. Then we're going to do the exact same for the other two, but we're going to mark them as group 2. Now we're going to right click on anyone and we're going to say find commonalities between addresses, scan for commonalities. Immediately it's given us quite a few commonalities over here, but what we're going to do is we're going to use RBX because remember that is where the actual pointer of the player has been stored. So let's double click on that and let's scan, and this is going to create a little scan. It doesn't matter what you call it. Let's save. I'm going to replace it, and boom, just like that we see all 4 of our players. This is the 2 on our team, the 2 on the enemy team, and we can now start looking and finding things that are common between them. Immediately we can see that at offset 14, the blue guys who are on our team have a value of 1, whereas the red guys who are the enemies have a value of 2. Now you could continue searching through this because I know that there are other commonalities that you could use, but just for the sake of simplicity, we've literally immediately found the team number. It seems like at offset 14, this is the perfect place for us to try and check the team. Keeping that in mind, I'm going to go ahead and close out of this because we already know that the offset is 14. And now we need to go and do some code injection. So we can close out of everything. I'm going to come back here and find out what writes to this address just to get that instruction back, which is this one, show in disassembler. Go ahead and close this. And now on this line, we are going to do some code injection. So let's go to tools, auto assemble, template. We're going to make a code injection template, and this is in fact the address of the jump that we want. And then we're going to go back to template and we're going to add cheat table framework code. So right here, we can actually write our own code that is going to be injected into the game, and then it's going to return and go and call the original code. So what we want to do is basically, if they are enemies, then we want to continue subtracting their health. But if they are on our team, we want to exit early out of this function. So how do we do that? Well, we're going to compare rbx plus 14. Remember, 14 is the location of the team number that we just found in that blue and green box. And then we're going to say a JE, which means jump if equal. So if these are equal, right? If it's equal to 1, then we're going to go ahead and JE to exit. Right, exit is this label down here, and it's that simple. So now we're going to go ahead and say file, assign to current cheat table, and we can go ahead and close out of that. Now you'll find that in this address box, we have auto assemble script. I'm going to rename this to freeze team health. Okay, and theoretically, if we turn the script on, you'll find that when we attack the enemies, their health still goes down. But if we try and attack our players, would you look at that? It doesn't go down. So we can restart the game, restart and autoplay, and just like that, the enemies died and we didn't die. Alright, so isn't that cool? We basically just added an if statement in the middle of the game with assembly through a method of code injection with Cheat Engine. And that basically completes the entire tutorial. If you go ahead and click next from here, it brings you to the tutorial games, which are pretty cool. Maybe I'll make another video about that in the future, but I've walked you through all of this stuff, and I think now it's time for you to go and try and hack these example games by yourself. All the techniques used, you've just been taught, so don't worry about it. Anyway, that just about wraps up the Cheat Engine tutorial. As I said earlier, there's a lot of good stuff in this tutorial, and I'd highly recommend practicing it and going through it yourself. If you get stuck, come back to the video and watch it to see how you get through it.
Anyway, ladies and gentlemen, thanks for watching the video, and I hope you enjoyed it. I also hope you had a great new year, and as always, shout out to my sexy patrons. You guys are awesome. I have a lot planned for this year, so if you haven't already, hit that subscribe button and drop a like. Until then, cheers and peace out.
Subscribe to cazz, bitches.